Hi, it's Mr. S, and today I have two videos. The whole videos is about distributive property, and this video, part 1, is about more focused on multiplication itself. The second video that I'm going to upload later is about the distributive property itself. So in this video, I will focus more on multiplication using a technique. I've seen a sorry, there's a bug again. I've seen students who struggle with multiplication, and I just wanted to show this technique so that might help them calculate some, especially those big numbers. Anyway, also this video is going to be kind of like an intro of distributive property. That technique is actually using some sense of distributive property, and we'll get to there later. But first, I'm going to talk about multiplication itself. Example, 2 times 4. You know that's 8. Here's a picture right here, diagram with the boxes or blocks. Yeah, 1, 2 blocks, 2 blocks, 2 blocks, 2 blocks. 2 times 4, 4 groups, that's 8. Now, 2 times 4 is 8, but multiplication, I want you to understand that multiplication is representing 2 plus 2 plus 2 plus 2. This 2 times 4 is representing 2 plus 2 plus 2 plus 2. Basically, how many times are you adding that number? That's what multiplication is representing. And you're gonna learn that. You've learned that multiplication when you're in 3rd grade, maybe 2nd grade, maybe 4th grade, somewhere around that. And once you get started, you are also going to start learning about area. Let's say you're given this picture with a description, maybe like Miss O has a garden that is 3 feet and by 4 feet. What is the area that she can use? And you'll say 4 times 3, or 3 times 4, and equal 12 feet squared. Or you might say, you can also think this way, 3 plus 3 plus 3. I mean 4 plus 4 plus 4. You can say 3 plus 3 plus 3 plus 3. Or you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And get 12. On area, your goal is to find how much are there inside that big rectangle, that whole big rectangle, this big one. How much are inside? How much can you fit inside there? That's what the area represents. How much are there in total? With that in your mind, when the struggle that I saw with the students while I was substituting is, let's say students are given like this number, 7 times 8. What they usually do, some students, and I'm not saying all, is they get this, calculators. 7 times 8 is on the multiplication table. They have, I'm pretty sure, I hope, they had enough practice and experience with multiplication tables, yet they still use calculators. They're not really confident. 7 times 8, it's like 50, whoa, wait, they have that kind of reaction. Instead of using a calculator, I'm going to show one technique that you might be able to use, and it's good for other numbers, like more, like much bigger numbers, like 20, 50, things like that. So I'm just going to use a table again, diagram. This is 7 times 8. 1, 2, 3, 4, 5, 6, 7, 2, 4, 6, 8. Yeah. And yeah, you can do like 1 plus 1, 2, 3, 4. You can count that. 1, 7 plus, 8 plus 8 plus 8 plus, But instead, the technique I want to show is split the numbers into numbers that you can manage. Here's what I mean. Let's say, oh my gosh, 8 is so big number, I'm not really confident. So let's break that down into 4 and 4. Like I said earlier, area is total in this big rectangle. That means you have to add the parts up to find the whole thing. Well, you can do 7 times 4, this part, the top part, 7 times 4 on the bottom, and add these two together and get the answer for 7 times 8. If you know 7 times 4 and 7 times 4, you got it. But maybe you'll be like, oh my gosh, 7 is still a big number. I'm not really good at it. Break it up again. 2 and 5. Now, if you have a question like, can I do like 5 and 3 instead? Or on here, can I do 3 and 4 instead? The answer is yes, sure, go ahead. Use the numbers that you are confident with. But if you're using ones, I mean, that's like, that's going to take a lot of steps. So, biggest manageable parts. That's what I would suggest. If you feel like 5 is big, you can do 2 and 3. But I think 5 is good number because 5 is pretty easy number. You only have 5 or 0 on the first digit, right? So once you split them and then you feel confident about managing those numbers, be able to do those numbers 2 and 4, 5, I think I can do that. Then all you gotta do is add the multiply the parts. 2 times 4, that's 8. 4 times 5, right here is 20. 4 times 2 on the bottom, that's 8. 4 times 5 is 20. Then add these 4 parts up. 20, 28, 8, that's going to be 40 and 16. So that is 56. That is one way you can do multiplication. Now, if you were to write it down using numbers and signs, the things that I just showed you looks like this. 7 times 8 is given. 8 is big number. I'm going to split them. 4 and 4. I put 4 plus 4. 4 plus 4 is 8. You can do 3 plus 5 if you want to. And then I have, okay, 7 is still a big number. I'm splitting it into 2 plus 5. And then 2 and 4, 4 and 5, 2 and 4, 4 and 5. You multiply those. You got 8 plus 20 plus 8 plus 20. And then last but not least, add them up, 56. Just kind of intro to the distributive property. Notice this part right here, 2 plus 5 times 4 plus 4. And it goes to this part, 8 plus 20 plus 8 plus 20. 2 times 4, right here, 2 times 4 give you 8. 2 times 4, that's 8 right here. 5 times 4 is 20. 5 times 4 is 20. Here, 2 times 4 is 8. 2 times 4 is 8. 4 times 5, that's 20. 4 times 5, that's 20. Just kind of show you that connection between these two lines in a algebraically and with the pictures. That's what I'm doing. So using this technique, you can do much bigger numbers like 18 and 24. You don't have a calculator, oh my gosh, you can do that splitting apart and break it down and multiply each part and add them up. You can do different ways, like you don't have to necessarily have to split that 18 if you don't want to. You can split that, hold on to that, and then split that 24 into 20 plus 4. But if you feel like 18 is big, you can do 10 plus 8. You can also do 20 minus 2. 20 minus 2 is still 18. Now, when you have negative, that means you have counted too much. So you have to subtract at the end. That's all it is. Or you can do 25 minus 1 for 24. Whatever you want to choose, you choose the number that you want to choose, that you want to use, okay? Now let me go back to this thing that you probably have experienced, that vertical calculation. I'm just calling it this way. I don't know what it's called, but 18 times 24, you write it vertically and calculate it vertically. You do this by 4. 8 times 4 is 32. Carry up 3. 1 times 4 is 4. Plus 3 is 7. Then next number 2. 2 times 8 is 16. I'm going to leave this part open. 6. Carry up 1. 1 times 2 plus 1 is 3. And on here, I'm going to add these down to bring it down. 7 plus 6 is 13. Carry up 1. 1 plus 3 is 4. And you got the answer 432. This thing right here, you got 432, and I want you to focus on this part. These two things, 72 and 36. 72 is a result from 18 times 4, right here. This part, 36, is a result from 18 times, it's not 2, it's actually 20. This part right here represents 0. It's yeah, you didn't write it down anything, or you might be asked to say, you might have been asked to write down 0. I mean, I wasn't, but this part represents 0. 2 plus 0 is 2, right? So you got this 432 by actually doing something like this. 18 times 4, 18 times 20, add these together, or write it down like this way, whatever it is. The point I want to mention is that you've done this vertical calculation, and it is somewhat related to the things that I just showed, the splitting things. You probably not noticed it, but you have actually done it before. Surprising? Now you might have a question. I mean, I've been doing addition all the time, but 7 times 8, can I split that 8 into 4 times 2? The answer is yes, it works. But I was using addition with, I have 2 reasons. One, distributive property. Inside the parentheses often have addition or subtraction, so that's why I want to introduce that. Number 2, I forgot what it was. But that was the big thing, to focus on the addition that relates to that distributive property. Now, 4 times 2, that's 8, and this still works. Parentheses, it's a multiplication. So basically, this 7 times parentheses 4 times 2 is actually nothing but 7 times 4 times 2. And if it's a multiplication, you go from left to right. So 7 times 4 is 28. 28 times 2 is 56. Put this in a diagram. This part is 7. This part is 8. 4 times 2, that's actually you're having 2 4s. 4 and 4. Having 2 4s. One on top, one on bottom. That's all you did. Obviously, you can't have this as 3 times 4. It's 3 plus 4. So if you want this as 1 times 8, well, that's nothing much changed, right? So, but this thing right here still works, but for my video's purpose, I was using addition. Okay. So that is the end of the part 1. Please check the part 2. It's about distributive property, about expanding the expressions, and it's going to help you when you are solving equations. Right. And see you later.